Section 220.20 of the National Electrical Code, or NEC, addresses the demand factors for kitchen equipment. The question often arises whether refrigerator equipment and remote compressors are included in this category. The answer is yes, both refrigerator equipment and remote compressors are considered part of the kitchen equipment and are therefore subject to the demand factors outlined in Section 220.20 of the NEC. To understand this, it is essential to examine the NEC definition of kitchen equipment. The NEC defines kitchen equipment as appliances such as ovens, ranges, dishwashers, sinks, freezers, and refrigerators, used in the preparation and serving of food. This definition is quite broad, and explicitly includes refrigerators. Refrigerators are used to store food at low temperatures to prevent spoilage. They are a necessary part of any kitchen, both residential and commercial. Without refrigeration, the safe storage of perishable food items would be impossible, making it a critical component in food preparation and serving. The NEC also recognizes that refrigerators often require remote compressors. Remote compressors are used to cool refrigerators. They are typically located outside of the kitchen, in a separate mechanical room or on the roof. The reason for locating compressors remotely is often to reduce noise and heat within the kitchen environment, as well as to provide better ventilation for the compressor itself, ensuring its efficient operation. The NEC acknowledges the integral role that remote compressors play in the refrigeration process. Since the refrigerator is considered kitchen equipment and the remote compressor is essential for the refrigerator's function, the compressor is also considered part of the kitchen equipment. This is an important distinction because it allows the entire refrigeration system, including the compressor, to be included when calculating the demand load for the kitchen. Demand factors are used in electrical calculations to account for the fact that not all equipment will be operating at its maximum load simultaneously. This allows for a more realistic assessment of the electrical demand, which can result in smaller service sizes and lower installation costs. Section 220.20 of the NEC provides demand factors for various types of kitchen equipment. Specifically, it allows for a demand factor of 0.65 to be applied to the total connected load of kitchen equipment. This means that only 65% of the total connected load needs to be considered when calculating the overall electrical demand for the kitchen. In the context of refrigerator equipment and remote compressors, this means that you can apply the 0.65 demand factor to the combined load of the refrigerator and its compressor. This can result in a significant reduction in the calculated load, especially for larger commercial kitchens with multiple refrigerators and compressors. It is important to note that the application of demand factors must be done carefully and in accordance with the NEC. It is essential to accurately determine the connected load of all kitchen equipment and to apply the appropriate demand factors based on the specific requirements of Section 220.20. Additionally, local codes and regulations may have additional requirements or restrictions regarding the use of demand factors. Firstly, it is imperative to understand the specific definitions and requirements outlined in Section 220.20 of the NEC. Secondly, it is crucial to accurately determine the connected load of all kitchen equipment, including refrigerators and remote compressors. Thirdly, the appropriate demand factor should be applied in accordance with the NEC and any local codes or regulations. Fourthly, all calculations should be carefully documented and reviewed to ensure accuracy and compliance. For example, consider a commercial kitchen with 2 refrigerators, each with a connected load of 5 amps at 120 volts, and a remote compressor for each refrigerator with a connected load of 3 amps at 120 volts. The total connected load for the refrigerators is 2 refrigerators times 5 amps equals 10 amps. The total connected load for the compressors is 2 compressors times 3 amps equals 6 amps. The total connected load for the entire refrigeration system is 10 amps plus 6 amps equals 16 amps. Applying the 0.65 demand factor, the demand load is 16 amps times 0.65 equals 10.4 amps. This means that instead of designing the electrical system to handle 16 amps of load, you can design it to handle only 10.4 amps, resulting in potential cost savings. It is important to note that this is a simplified example, and the actual calculations may be more complex depending on the specific equipment and installation. Factors such as voltage, power factor, and conductor rating may also need to be considered. In addition to the demand factors for kitchen equipment, the NEC also provides demand factors for other types of loads, such as lighting, heating, and air conditioning. These demand factors can be used to further reduce the overall electrical demand of a building. However, it is essential to ensure that the application of demand factors does not compromise the safety or reliability of the electrical system. The electrical system must be capable of handling the actual load that is likely to be imposed on it, even if it is less than the calculated demand load. Therefore, it is crucial to carefully consider all factors that may affect the electrical demand of a building and to apply demand factors judiciously. In conclusion, refrigerator equipment and remote compressors are considered part of the kitchen equipment under Section 220.20 of the NEC. This allows for the application of the 0.65 demand factor, which can result in significant cost savings. However, it is essential to apply demand factors carefully and in accordance with the NEC and any local codes or regulations. All calculations should be carefully documented and reviewed to ensure accuracy and compliance. Ignoring the need to assess the compressor with the refrigerator and only looking at the refrigerator itself would be incorrect. The compressor, being an integral part of the refrigeration system, is to be included in the overall load calculation and subjected to the same demand factors as the refrigerator. This inclusive approach ensures that the electrical system is adequately sized to handle the combined load of the refrigerator and its compressor, preventing potential overloads and ensuring reliable operation. Always refer to the latest edition of the National Electrical Code and consult with a qualified electrical professional for specific applications and interpretations. The code is updated regularly, and interpretations can vary, so staying current is crucial for safe and compliant electrical installations. Remember to document all assumptions and calculations, and to have them reviewed by a licensed electrical engineer or inspector. This helps to ensure that the electrical system meets all applicable requirements and provides a safe and reliable source of power. It is crucial to consider the nameplate date of the refrigeration equipment and remote compressors. The nameplate typically provides information such as the voltage, amperage, and power factor of the equipment. This information is essential for accurately calculating the connected load and applying the appropriate demand factors. Additionally, it is important to consider the operating characteristics of the equipment. For example, some refrigerators may have a higher starting current than running current. This could affect the size of the conductors and overcurrent protection devices required for the circuit. In some cases, it may be necessary to provide separate circuits for the refrigerator and the compressor. This can help to reduce the impact of the starting current on the overall electrical system. Additionally, it can provide better protection for the equipment in the event of a fault. When designing the electrical system for a commercial kitchen, it is also important to consider the potential for future expansion. It may be necessary to provide additional capacity in the electrical system to accommodate future equipment addition. This can help to avoid costly upgrades in the future. Additionally, it is important to consider the location of the equipment. Refrigerators and compressors should be located in areas that are well ventilated and free from obstructions. This can help to ensure that the equipment operates efficiently and reliably. In addition to the NEC, there may be other codes and standards that apply to electrical installations in commercial kitchens. These codes and standards may address issues such as energy efficiency, fire safety, and sanitation. It is important to be familiar with all applicable codes and standards before designing and installing the electrical system for a commercial kitchen. Furthermore, it's beneficial to understand the general principles behind demand factors. Demand factors are statistical measures used to estimate the probable maximum load on an electrical system or portion thereof. They are based on the assumption that not all connected loads will operate simultaneously at their maximum rating. The demand factor is the ratio of the maximum demand of a system or part of a system to the total connected load of the system or the part of the system under consideration. For instance, a demand factor of 0.65 implies that the expected maximum demand is only 65% of the total connected load. This reduction is due to the diversity of loads, where some appliances or equipment operate intermittently or at less than full capacity. In the context of kitchen equipment, the 0.65 demand factor acknowledges that not all kitchen appliances, including refrigerators and their remote compressors, will be running at their maximum rated power simultaneously. This is a practical consideration, as cooking cycles vary and refrigerators cycle on and off to maintain temperature. Applying this demand factor helps to avoid oversizing the electrical service and distribution equipment, leading to cost savings and improved efficiency. To properly apply demand factors, one must accurately determine the connected load of each appliance or piece of equipment. This information is typically found on the equipment's nameplate, which lists the voltage, amperage, and power requirements. For refrigeration equipment, the connected load would include the power required by the compressor, condenser fan, evaporator fan, and any other associated components. The sum of all connected loads in the kitchen represents the total connected load. Once the total connected load is known, the applicable demand factor can be applied to calculate the demand load. The demand load is the estimated maximum load that the electrical system is likely to experience. This value is used to size conductors, overcurrent protection devices, and other electrical equipment. In addition to the specific demand factor for kitchen equipment, there may be other demand factors that can be applied to reduce the overall electrical demand of a building. For example, the NEC provides demand factors for lighting, heating, air conditioning, and other types of loads. These demand factors can be used in combination to achieve the most accurate estimate of the building's electrical demand. It is important to note that demand factors are not always applicable. In some cases, the electrical system must be designed to handle the full connected load. This is typically required for critical loads, such as emergency lighting and fire pumps, which must be available at all times. Additionally, some local codes may restrict the use of demand factors or require more conservative estimates of electrical demand. Therefore, it is always necessary to consult with a qualified electrical engineer or inspector to determine the appropriate demand factors for a specific application. Another consideration is the power factor of the refrigeration equipment. Power factor is a measure of how effectively electrical power is being used. A lower power factor can result in increased current flow and higher energy losses. Some electrical utilities may impose penalties for customers with low power factors. To improve the power factor of refrigeration equipment, power factor correction capacitors can be installed. These capacitors provide reactive power that offsets the inductive reactance of the equipment, resulting in a higher power factor. Power factor correction can reduce energy consumption and improve the efficiency of the electrical system. When selecting conductors for refrigeration equipment circuits, it is important to consider the ambient temperature. The ampacity of a conductor is the maximum current it can carry without exceeding its temperature rating. The ampacity of a conductor decreases as the ambient temperature increases. Therefore, it may be necessary to use larger conductors in areas with high ambient temperatures. Additionally, it is important to consider the voltage drop in the conductors. Voltage drop is the reduction in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. The NEC provides guidelines for limiting voltage drop in electrical circuits. To minimize voltage drop, conductors should be sized appropriately and kept as short as possible. The type of overcurrent protection device used for refrigeration equipment circuits is also important. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical equipment from overloads and short circuits. The NEC specifies the type and size of overcurrent protection devices that are required for various types of equipment. For refrigeration equipment, it is important to use overcurrent protection devices that are specifically designed for motor loads. These devices are designed to handle the high starting currents that are typical of motors. Additionally, it is important to coordinate the overcurrent protection devices to ensure that they trip in the correct sequence. This can help to prevent damage to the equipment in the event of a fault. Grounding is another important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and to energize the circuit. All electrical equipment should be properly grounded in accordance with the NEC. Additionally, it is important to use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock. GFCIs are designed to detect small amounts of current leakage to ground and to quickly de-energize the circuit. This can help to prevent electric shock injuries. Finally, it is important to perform regular maintenance on refrigeration equipment and electrical systems. This includes inspecting and testing the equipment, cleaning the coils, and checking the wiring. Regular maintenance can help to prevent problems and ensure that the equipment operates efficiently and reliably. It is also important to keep accurate records of all maintenance activities. These records can be helpful in troubleshooting problems and planning for future maintenance. By following these guidelines, you can ensure that the electrical system for refrigeration equipment is safe, reliable, and efficient. Always consult with a qualified electrical professional for specific applications and interpretations of the NEC.